All right, let's talk about week 4. Is it time? That's time. I put some extra files up there today under week 4. I actually updated the slides a little bit. And I put some files they reference in the book. So we're going to talk about some of these today. So if you want to download those from there, save you some typing. So I'm just saying. I also updated the slides a little bit. So has everybody been able to find the recordings and everything? Because I know someone emailed me said they couldn't find it, like the in-class exercise. If you miss an in-class exercise, well, it's obviously an in-class exercise. Yeah. So I do give you a little bit of time to submit it after the fact, and I don't post what it is other than it's due. And you can always look at the recordings to find it. So, you know, you can go in, you know, you just have to watch the recording.
It does just send me to YouTube. I don't know if that's what it's supposed to do, but it acts like it's going to play, and it doesn't play anything. And then I click the link, and it takes me to YouTube.
It needs to be open a new browser window.
Yeah, just like that, exactly. So it's not hard to find. I gave you a thumbs up on one of them. So there you go.
So it does take you, that's what it's supposed to do. So it's go to YouTube. Yeah, I put everything up on YouTube. That way.
I subscribe. Do I get extra?
No. That way it's easier for everybody to find them.
I turned off my ad block for watching.
There's no ad blocks on this. I don't know. But does it have pop-ups or something?
Oh, yeah.
Yeah, I don't monetize my videos. I guess I should. Maybe I'll make some money on this.
Make some video.
Makes you have to watch 85 ads. Don't you hate that? You know what the worst thing I hate is? When you're watching a trailer for a movie, and they make you watch a trailer for a different movie before you can watch the trailer for your movie. It's like, I'm watching an ad. Now you can make me watch a different ad before I could see your ad.
Man, when they hit me with that double ad,
it's crazy.
I had a trailer play before the trailer.
I know, it's crazy.
The same movie.
Who does that?
Same movie.
Yeah. All right.
You watch.
I can't wait to watch the trailer.
Oh, there? Wait. Chapter 3.
It's like a teaser trailer for the trailer that you're going to watch.
I'm going to put a file up there for today. Now, some of you noticed last time that it does help sometimes to follow along, especially if I say you're going to have to submit something. The right summary.
Hey, listen, I was, okay? I was just playing with what you were doing just in my own way.
I don't know.
I got the concept, so.
Yeah. All right, so I'm going to open this. Now, you do realize what's happening Wednesday, don't you?
No, what's happening Wednesday?
This is a very important week. Got stuff happening all week. Wednesday, Apple's going to tell you what phone you need to buy now.
Oh, it's their.
Jeez. Seriously?
I thought they already announced it. It's the iPhone X Max.
S Plus, whatever.
The iPhone.
But I'm just letting you know that I'm not going to watch it live because of y'all.
Because
You
could run it in the background.
What?
Well, the next
We could watch it during class.
Exactly.
Yeah.
But they made the 8.
All right, let's start talking about Chapter 3.
And then now they're already
Decisions, relational operators, okay? The slides are up there if you want to download them. I got to make them so they're not full screen. That way I can do other stuff as well. Okay, hopefully we're going to learn about decision statements, about different data types. Now, did everybody get the assignment done?
Yeah.
Yes.
Actually, let's talk about that for a second. Let me pause this recording. Okay. So we're going to talk about decision statements, and there's a lot of people who have a lot of issues with this stuff. We're only going to do about half of it today. We're going to talk about the if statement, relational operators, nested branches, and multiple alternatives, just all kinds of different stuff. Okay. If statement. So Friday, I was supposed to go to the Del City Cobb football game. Did anyone go to that game? No one went to it?
No.
Rained like crazy. And 1 minute left in the game, Del City was ahead by 2 touchdowns. Cobb got 2 touchdowns in a field goal and won by 1 point. Wow.
And that's Del City for you.
But I was supposed to go there because Rose State is sponsoring Mid-Del this year. I think we give them $20,000 or something. So we have a table at each game where we can have someone advertise or whatever. So they wanted me to go there and talk about cybersecurity program if anyone had any questions and hand out brochures. But my question was, If it's raining, I ain't going. Make sense?
Yeah.
If I'm going to be sitting at a table handing out brochures in the rain, what good would that be?
Right.
So I basically told our marketing department, if it's raining, I will not be going. It turns out it was raining. My wife went because my stepdaughter's in the ROTC. She runs the flags. But yeah, she goes, at 6:30 it was raining. By game time, she was totally soaked to the bone and came home before halftime. So, but if statements is things like that, should you do something? If it's raining, bring an umbrella. Or if it's raining, don't go. Or if it's Monday at 12:30, be in class. That kind of stuff. Okay. So it says a computer program often needs to make decisions based on input or circumstances. Okay. You could skip. Anyone ever been on a cruise ship?
Yeah.
Some of you. You ever notice they don't have 13th floor?
Oh, I
They
don't
don't.
know. Sit on them.
They don't.
You said what?
They don't have the 13th floor. So you go from 12 to 14. So if you see you're on deck 14, you're technically not on 14. You're technically on 13, but they don't have a 13. They don't have a 13, so they make it 14.
Yeah, this is something about it's like a legend in
Oh,
boating. Like you can't have that. It's bad luck for your boat because it'll make it sink.
Yeah, it's like you can never ring the bell, that kind of stuff.
Yeah.
So, it's kind of funny, but we could use an if statement for that. If someone enters 13, go to 14 or whatever, okay? And we have if and we have else. So if something's true, else, do this, else do something else. Pretty simple there. So here's a branch. Here they have if, so basically this is a decision structure in the middle here, this diamond, okay? So is the floor greater than 13? Yes or no? Whenever you have a decision structure like that, there always has to be a yes or no on it, or true or false or something, okay? So say if it's greater than 13, the actual floor is the floor minus 1. So in other words, if someone enters 14, so it's greater than 13, it's technically the 13th floor, just like I said, okay? Easy enough there. And there's the code they did to write it. Be careful because you must add the colons in Python. If you forget the colon, it's going to give you issues. Okay, so now you must add the colon. I'm going to make this a little bit bigger. All right. Okay, and that's pretty much, this is flowchart with only a branch. So if something's true, now false, we're not doing anything with it because we could care less if it's false in this case, or it could just go to the end, but nothing really special there. The syntax of it, I think they go way too much in depth, but if the condition, like they're saying up here, if the condition is true, do this. Now over here, if the condition is true, do this. If it's false, do this. Now you can also have something called else if, we're going to get to in a second where you could have more. So if the floor is greater than 13, the actual floor is the floor minus 1, or else the actual floor is equal to 4. Okay. Okay, here is the elevatorism program. We're not going to walk through this one, but it can be used to check stuff. Actually, I don't think I put elevator up there, did I? Actually, maybe I did. Maybe I did. Yeah, I did. Didn't I put elevator up there for you guys?
Yes, you did.
Okay. Let's walk through the elevator program real quick. Yeah, this is section, I think it's in chapter 3, section 2, I think is the elevator. Let's compare. What is section 1? Okay. So, yeah, this is the program we just saw. So my floor is the 12th floor. Elevator will travel to the actual 12th floor. Now if I run this again, now if I put in the 15th floor, it'll actually travel to the 14th floor because since it's greater than 13, we're going to go to the floor minus 1. Easy enough to do. Okay. So I put these up there because you might need one of these for one of your assignments as an example. So, okay. Now, how can we check if it's equal to 13? Anybody got an idea? Double equal sign, yes. Single equal sign. Now, I don't know if this will work. It probably won't. No, it does not. It's funny because I don't know if anyone's ever written a Java before, but an earlier version of Java allowed that. And what would happen was it basically read as if floor is equal to 13, so that's true because it's set 13, so your loop is always true. Not your loop, your section was always true. So in Java, if you put a single equals, it was always true no matter what. It wasn't until later versions of Java that they fixed that. Like, no, you must have a double equals. Now it'll work. So if it is 13, so let's see, 14, put a period there, my bad. Do it again. So if it is 14, it's going to go to the actual 14th floor. Because now I made it where it only does something if it's actually 13. So now if I say 13, I should go to 12. Okay. So very easy to play with this. Nothing special. All right, we already ran it. We already saw a couple of examples how to run. Any questions on that? If you have questions anytime I'm going on, based on some of the programs that people submitted and comments, some of you might have questions. If you do, please ask. I have no problem answering them. And by the way, I'm always here in the mornings as well. I know a couple of you came and saw me this morning, which is fine. So yeah, I'm usually here 7 days a week in the morning. So, all right. So first example 2. They talked about the equal sign. We're going to talk more about that here in a second. Now let's talk about compound statements. I'm not going to show you. Okay, they span multiple lines. It consists of a header and a statement block. And if the if statement has multiple lines, you need to have a colon after the if. And we're going to see an example here in a second. There it is. Okay. Just like the other if statement, but these if statements, you'll notice there are more than one line in there. Okay. So we need the colon and then just indent them. Other languages like Java, with one statement, you don't need braces. But if you have more than one statement, you need braces. So I think it's the same way for C. Not positive. But if you have multiple lines, just indent them over. That's how Python does everything. It's all indented. That means this code is indented from there. This code is indented from there. If you were to unindent one of these, it would cause an error. It definitely causes an error. So if you ever get a comment about indenting, that's what it is. You indented correctly. Okay. Common areas is avoid duplicates in branch. So here they have the same thing on multiple times. Wait, what are they doing? The same code is duplicated in each branch, then move it out of the branch. Well, okay, what they're talking about there is, here we have the same code twice. So if it's greater than 13, subtract 1 and then print out the floor. Or else, do not subtract 1 and print out the floor. Well, we actually duplicated this word, okay? See how that line's in there twice? Is that a big deal by doing that? It's not a big deal, but you had to type it twice. Down here is the same code, but the duplicate line has been removed. Since this line pertains to both the if and the else, why have it in there? See what I mean? So now we're just going to determine the floor and then output it. There's a lot of times, I think I mentioned before, we played code golf where you try to figure out to get it shorter. We just saved a lot of code by doing that. It doesn't sound like much, but watch Apollo 13, you'll understand how that works. Okay. Now, conditional operators. There's a shortcut you can find existing code. It's not using a block. It's a shortcut notation. Now, what shortcut notation is, let's give an example. Trying to think of an example. We'll walk through their example. Okay. Let's look on the right-hand side. I can't think of a good example at the moment. Floor minus 1, this is the branch. So floor minus 1 is the actual floor. Okay? And over here, if floor is greater than 13, else floor. What are they doing with that? If floor is greater than 13, that's wrong. The way they wrote that's bad, because that's the way it's actually done.
They did that on purpose.
Oh, I think they did it on purpose just to make it look stupid.
Yeah, it says it at the bottom.
Oh, the shortcut is difficult to read. Yeah, okay, that's what they're saying. It's very hard to read. Yeah, that's a bad idea. That definitely is hard to read. Okay, but we're going to see about conditional more here in a minute. Okay, and there's our if statements again. Now we have greater than or equals. We have less than or equals, or equals to. Easy enough there. Y'all understand what all those things mean? Greater than, all those? Okay. Nothing special there. Assignment versus equality. Here's what I tried to show you earlier. Assignment operator is a single equal sign. That means it takes the value 13 and assigns it to the variable floor. Easy enough. With double equal sign, now it's a relational operator, or it's checking equality in this case. So now we can use it. The answer is either true or false. Has to be true or false. Can't be anything else. Okay. Comparing strings. Here we have if name is equal to name 1. They're identical. Now this varies upon languages. Java has a big issue with this. You cannot do this in Java. The reason I keep bringing that up is some of you might take a Java course. But in Python, that's how you do equality, which kind of sucks that it's exactly opposite from other languages. Okay. And here it's not. Actually, that won't work. Does that work? Let me try that. We're going to try this real quick. Okay. Name 1 equals Ken. Name 2 equals Bob. If name 1 not equal to name 2, print hi. Good. Actually, it does work. I thought I had to use not in this. I couldn't remember if that one worked or not. Yeah. So it does work in here. It doesn't work in all places, though, in Python. That's not. And I think you can also. That one work? Can't remember. No. Try this one. We're going to see in a minute where that does work the other way. But that's how they do not in this case. Okay. I can never remember which one does what. There's too many of the darn things, especially when I teach both of them. It drives me crazy. Okay. So these two strings, are they equal, first of all? Yeah. Yes, they are. So in that statement, we'll check that. Now here, they're not equal, so they would become different. Now in Python, you also notice that the W is not the same. So if one's uppercase, one's lowercase, that's not going to work either. Okay? In other words, they're not going to be equal. If you want to be equal, everything needs to be equal, including spacing and capitalization and all that stuff. Okay. All right, and yeah, and that one's backwards. So it says the less than or equal sign is that, not that. You can see on their example here, it has to be the less than first. That would read if 3 equal to or less than, now it's supposed to be less than or equal to. Okay. And this one down here, okay, 3 equal, they have a single equal sign, so it's supposed to have a double equal sign. And the last one, 10 greater than 5, we can't check equality of a string compared to a number. So just some different errors people have. Okay. Here's another one. Same thing. 3 is equal to 6 divided by 2. That's not right. We need a double equal sign there. And that is the same one. Why are they listed twice? Who knows? Okay. It was twice, wasn't it? Yeah, it was at the bottom. Who knows? Okay. Now let's talk about floating point for a second. Floating point numbers are decimal numbers, normally very large numbers, okay? But they have what's called limited precision. In other words, if they get very long, it's very hard for them to work. And actually, you probably never see it, but I have seen it before, where sometimes numbers just don't work, and you might want to round it off. I actually included an article here. Did anyone buy a computer way back in 1994? Did you buy the Pentium 66 with a floating point error in it? I did. I remember it came out right around Christmas time, right before AMD came out with one. So they sold them all, and it turns out they actually had an error. It was actually a hardware error. It says, the process for floating point divide problem was caused by a subtle but specific circuit design error. The flaw was easily corrected with changes, and basically what happened is, a month later, they give you a brand new processor for free. So floating point could, and I think the error caused an error like in the 4,000th decimal place or some stupid thing that we'd probably never
You
see.
could fix it. So say instead of dividing by 2 multiple. This isn't exactly the right thing, but if it gave you an error by dividing by 2, you could multiply by 0.5 instead to fix the error, and it rerouted the electrons in it somehow. So that's how you got through that. I remember that floating point error.
Yeah, and I remember they just gave us all free processors. They did it because they wanted to get on the market before AMD did. Okay, so just remember they matter. Okay, especially when you work with decimal places. You want to round it to make sure you get the right value. And sometimes we'll be doing some sort of math and checking equal to, less than, greater than. You'll end up with an issue. That's why it's not really good to ever check equality with floating point numbers because of this problem here. It's just weird the way they work. Okay. So here we have square roots. You see 2.0 squared is not 2, but it's actually that number there. Isn't that crazy? So square root of 2 squared is not 2. It's actually 2.0, whatever. So I don't know exactly why. It just is. There's a lot of numbers like that. It's like, what is 10 divided by 3? Yeah, 3 forever. Okay. It'd be very hard to actually check that if it's equal to something because it's technically not 3.33 or 3.333 or 3. Whatever. It's a whole bunch more than that. Okay. Now, logical errors is to compare strings in dictionary order like. Now, all uppercase letters become lowercase when using that, which is weird. Spaces comes before all the printable characters. Digit become all before all letters. And it's just weird the way that works. Okay, it's called the lexicographical order. That's crazy, but I don't know. I've never had an issue with that actually. Okay, operator precedence. This is the comparison operators have lower precedence than arithmetic operators. So it's going to add floor plus 1 first, and then assign it to the actual floor. Okay? Makes sense, actually. So on the second example, it's going to add 1 to height, and then check if floor is greater than height. That does make a difference. Because say maybe floor is 13 and height is 13. Okay? If we check the relation first, if floor is greater than, 13 is greater than 13, the answer is false. Actually, go the other way around. But yeah, you can see here that it does this part first. It does the addition first and then does the checking. Okay, easy enough there. Implementing them, decide on a branching condition, original price less than 128, write pseudocode for it. So I haven't really required pseudocode yet, and I don't know if I will. Hopefully you did a lot of that in the fundamentals class.
Yeah.
Did I tell you about the program I wrote? I told you about the program I wrote before D2L and all that, WebCT.
Yes.
So, I mean, designing stuff really makes a difference. And you were even saying how you had something wrong on yours, didn't you? Or you were coming up with some weird number, you just said?
Yeah, because of the calculations I was making.
Right. So, I mean, if you actually sit down and think about how things work, so pseudocode does help. I'm actually having some work done in my house, and I had to, you think about it. If I'm going to build onto my house, add a room to my house, we could just go do it. You agree? Mm-hmm. We could just have to go and come and do it. But what are the odds that it would actually work out correctly? When they built my house originally, my living room is too wide. So when they came to inspect it, they found out that the rafter had to be made double sized. So the blueprints weren't correct in that case. Because you actually take the blueprints up to the assessor's office, get a building permit. It's not the assessor's office. Wherever you go to get a building permit, and they should have looked at the blueprint and found it was wrong. For mine, I just went up there like 2 weeks ago. It's a nightmare. I had to give them blueprint of the renovation. I had to give them a site plan. I had to give them all this stuff. Basically, I had to give them the pseudocode of the renovation. What I'm adding, what components could be involved with it. Then they came back with a list of rules. When the framing's done, you must get inspected. When the electrician's done, you must get inspected. When the plumbing's done, you must get inspected. And I had to have certain, I have to have a CO2 detector and all this other stuff in the room. So basically what they did is they looked at my plans, which are basically pseudocode for the renovation. And that's what I'm going to be designing by, so they checked them. And actually when you write software, there's something called the CMM model. I'm assuming you never heard of that, Capability Maturity Model. It tells you the proper way to write software. So do you all agree that designing would probably be the first step? Or look at your requirements and designing it. Then do you think you immediately go and start writing code from that point? Makes sense. But really you shouldn't. You're really supposed to have somebody else analyze it first. Somebody else, somebody else to look at it and see if you've screwed anything up. So he writes the pseudocode. Well, then he goes and writes this program. What if there's a problem in pseudocode? So he writes the pseudocode, and then there's normally a meeting, a peer review meeting where people, you all get together and look at it. But again, we're talking bigger programs, and you hopefully find the errors. Okay. But in their example here, you could write the true branch, you could write the false branch, and then we could very easily convert this. Okay, we haven't looked at the next slide yet. So the branching condition, overall price is less than 128. So we could say something like, if overall price is less than 128 colon, and then we would have this branch, else this branch. So it's very easy to convert pseudocode into actual language code, okay? And double check values, relational operators says here, check it for the different conditions. If you entered 128, check it for 127 and 129, make sure it's actually catching everything. Okay, remove duplication. I already talked about that on the other one. Test both branches, make sure they work. And I already did. I already wrote it for us, it's right there. Okay. So, all right, let's walk through their code here because I didn't copy this one out for you. Okay. Says there's an original price. If the original price is less than 128, it's equal to 0.92. And else, so this will be the true, this will be the false. Easy enough to follow there. I mean, if and else is really basic. I'm assuming all of you have heard of it before. Okay. And then we got remove the duplication because we put our print statement at the very bottom, or not our print, our assignment operator at the very bottom. It just kind of price. Okay. Open sale, I don't think, did I include sale.py up there? I don't think I did. No, I didn't. Yeah, this one was too short. I don't want to do this one. Okay. Now let's talk about nested branches. So if a customer orders wine, ask for the ID, then if they're over 21, serve them wine, else tell them you can't have any, basically. So that would be the pseudocode for a nested statement. Now here we have a flow chart of the same thing. Let's walk through this. So ask for an order. Would you like wine? If you say yes, they're going to check our ID. If you're greater than 21, serve the wine. Or if you're, in other words, if it's false, if you're less than 21, read the law to them. Sorry, you must be 20-year-old, have wine. Okay. Now, getting back to the false part again, that's if you wanted wine. Now, if you don't want wine, that would be false. Serve a non-alcoholic drink. Yay. So it's very easy to have multiple or nested if statements. Okay. We could have done it, you know, different ways, but that way it doesn't work. Okay. Did I have the tax rate up there? Yes, I did. Tax rate's up there, isn't it? Tax. Let's look at the taxes program. That's in section 3. I'm going to open up the taxes program. All right. Let's look at theirs. Now here we have in basically nested if statements, but not just nested if, we have nested if else's. So here we have if the marital status is single, then we're going to check if their income is less than the limit, then give us a tax rate. So this else, how do they get to this else statement? What has to be true?
If they're equal to single.
So they have to be single to get to here. And their income must be greater than their income has to be greater than the limit. Okay, see how that works? So this one, they have to be single and less than the limit. This one's single but greater than the limit. And then determine the tax rate and how much money they get. So this one here, they could be married or have a household or whatever. Then over here, again, they're checking this, but now we're using the married limit. To get to this one, they would have to not be single. That would have to be false to get to here. And then we would do the same thing, but based on the married limit. Okay, so pretty simple. Okay. I don't think, let's see what it does. I'm going to walk through this once. Enter income, $10,000. Okay, $1,000. Just got a deduction to pay. Your tax is $100. Okay. Stop.
It's like 10% tax.
So let's do it with 10,000 this time. Actually, $10,000 single. You have $1,000. That's a 10%. So let's do 100,000. Is it 100,000? It's 10,000. One more. There we go. Wow, $20,200. So that's
20.2%.
yeah, because 10% would have been $10,000, correct?
Mm-hmm.
So now that we made more money, our taxes, basically our taxes are going way up. Now let's check it if you're single.
Yeah,
Okay, so 10,000.
was single.
I'm sorry, married. What are we doing? 10,000, 100,000. There's 100,000. You're married, so your tax is less, isn't it?
$7,000.
Hold on, we got to run the other one again. We're going to compare this. You want the
It was
tax?
100,000
if you're single.
20,000 too. So it was about $7,000.
100,000 if you're single.
I think 60.
So you have a lot less tax if you're married. You notice that?
It was like $6,800 difference.
Yeah. So what's this telling us? We all need to get married.
Make a lot of money.
Calculate the stress levels of that.
Yeah, that's true. Yeah, it's like the coolness factor and all that.
Insurance
Well,
and stress levels are overloading.
there we go. There's our limits right here. Yeah. 32,000. Married to you know our taxes are changing this year.
Yeah.
Our personalization is going way up, like 14,000. But we can no longer claim kids.
Can't claim my kids.
No, but what they're doing is they're giving you that money anyway. So rather than what was it, like $3,600 for a kid or something, and a $6,000 exemption, now you're just getting like $14,000. So you actually
more.
Yeah, you're actually getting a better exemption. They're going to make it so a lot less people can file a Schedule A. So, I still will, but a lot of people won't be able to. It'll be cheaper if you don't. All right. So there's taxes. Also, how taxes work, pretty simple there. And here was our nested if statement. We already looked at that. There's the rest of it. Okay. Running it, we already looked at it. We looked at it a couple different ways. Oh, we didn't enter that for the marital status. All right, hold on. Let's do this again.
Is this a part of what Trump did, or is this a
Trump
Is it this Trump?
He eliminated most of the itemization things and just doubled the base. You can exempt them.
Okay, so now we're going to put in ampersand for single or married. So what does it do?
The tax is $1,000.
So let's
You're
run
an
it
and
again.
symbol.
To run it again,
We should have done an error.
$100,000. So which one is it calculating? It's calculating married. If we go back and look, because we're checking if it's single, do this one,
You never checked it.
or everything else, do this one. So what if you're a head of household?
Screwed.
You're getting the married rate, which is actually better. Okay? Because I tell you,
We don't
what
know
was
what
it?
you are. Sorry.
2 years ago, 3 years ago. TurboTax had a error in their code. I don't know what it was, but they actually contacted me and says, we've disabled the ability to ledger on a file temporarily so we can go fix it. Because you can see how, how many lines of code is TurboTax? Probably millions. And one little thing like this could cause a big issue. Cause a lot of problems. All right.
I want all my money.
So now we know why, because it's if single or everything else. Okay, hand tracing. Hand tracing is very handy. I was helping him earlier today because this program had an error. And we figured out he had to force one of his input to be float for it to work correctly. Sometimes you literally got to walk through it step by step and see exactly what it's doing and then find it. So
I had to move a couple things.
So it helps you understand whether a program works correctly. Okay, testing your variables. Works with pseudocode or code. Okay, that's what they did to me. The hand tracing of my blueprints for my house. So, okay, so hand tracing kind of handy. And normally when you do this, you should make a chart so you can test it with different values. And then look at the math you're doing to see if the math is correct. Easy enough there. Get your calculator out and do it. All right, we're not gonna walk through hand tracing this. Okay, increment testing code. It says using the flag program statement as an example. I didn't see the flag program. Did they give us that one?
No.
I don't remember seeing that one. Compute the data for the first panel, print the data code, or that's not what they're using either. Which one is the one? We didn't see the flag program, did we? What the heck? What are they talking about? You're not
The
earthquake
interesting
yet.
part of the video is you're like, I was believing it.
Yeah, I don't know either. I don't know where it is. So we're gonna give up on the flag program. We're gonna move on to the next part. Okay.
Oh, dang.
Okay, so what if you have more than 2 branches? So it says, count the branches of the following earthquake effects example. So we can have an earthquake 8 or greater, 7.99, 6.99, 4.5 to 5.99, or less than 5. So we obviously have more than 1. We obviously have more than 2. We end up having 5 different branches. Okay? All right. So how do we do that with an if and an else statement? You actually could, believe it or not. But what they do here is they're saying, so if it's greater than or equal to 8, most structures will fail. That's true. If it's false, we're checking if it's greater than or equal to 7, many buildings are destroyed, so on and so forth. Okay? So they're really only checking 4 times, because if you notice this last one here is less than 4.5, so it's basically everything else. But now we're going to go see, we're going to see it here in a minute, but there's something called an else if or elif in Python. Okay? It's short for else if. It gives us an option to test other things. Now, here's our code. If the Richter scale is greater than 8, greater than or equal to 8, print out most structures fail. Elif, in other words, else if the Richter scale is greater than 7, or 6 or 5, whatever. So you see how that works? So it's basically else if this is true, else if this is true. Okay. Now what's wrong with this code here?
It's just a bunch of ifs.
What now?
It's just a bunch of ifs.
So it's a bunch of if statements. So if we're going to walk through this, okay, 9.0. Let's walk through. If the Richter is greater than 8, so 9 is greater than 8, so we're going to print out most structures fail. It's also greater than 7. So now we're going to say many buildings destroyed. So what if rather than printing this out, we were like storing in a variable somewhere, then we printed at the very end? What would we get? Because 9 is above 8, it's also above 7, it's also above 6, and also it's above 4.5. So what ended up happening, it was damage to poorly constructed buildings only. It wouldn't have the rest. So, yeah. The code looks good, but it's missing the elifs. Elifs There's also something in Java called a switch, also in C, is just not available in Python, which
So-
makes it even better.
So the only way to fix that would be put an else statement, or would you just turn those other ifs to else ifs?
Make them into else.
Okay.
Yeah. What you could have done is you could have indented these,
Oh,
it's
yeah.
greater
yeah,
than-
yeah.
but you would have had to redesign the whole thing. Yeah, you'd have to change it all up because it still would be wrong, but okay. Or you could also do and. If Richter is greater than 8 and less than 10, or the second would be if Richter is greater than 7 and less than 8. If greater than 6 and less than 7, you could have done that. That would have fixed it. But the LF just makes it easier. Okay, so let's open the earthquake file. It's in section 4. Let's see what this one does. All right, so we are going to run this program. I'm going to put it in 9. Most structures fail. Now let's change these to just ifs. Nine. Yeah. And what if we had done this? What if we had done
Now the code's all kinds of messed up.
oh, we're gonna fix it.
Oh, don't do that. I wish that would work.
Okay. Now to save. Print. Now. Okay. So now let me run this code. So if I say it was a 2, no destruction of buildings. Okay. So let's go up to a 4, no destruction of buildings. So we're still good. Good. Now let's go up to a 6. Now we have damage to poorly constructed buildings. Now let's go to 6.5. Damage to poorly constructed buildings. Now let's go to 8.5. Damage to poorly constructed buildings. So you see the problem we have now?
It's not showing the higher ones.
It's not showing the higher. So what's happening is whenever this if statement is true, we're setting a value to this variable output right here. And then we're printing out the result. What's happening is each time it's replacing what's in output. So we end up with the last one no matter what. So now if we do the LF,
No, I never found.
okay, now we're going to do 9.5. Well, structures fail. Let's check
Fall.
many buildings considered damaged, some collapse. So, I mean, a little change of LF to just if can be a big problem. Because I will tell you, I see a lot of people doing this. They write if. Because what's happening is it's literally having to check each one, and it could mean both, more than one. So it could mean multiple.
I think I've done it to where it's if, but it was like you were talking about inside each other.
Right. Or different things.
Yeah.
Okay. So easy enough there. Everybody kind of understands how that one works? Okay. Now it says using flowcharts to develop and refine algorithms. Flowcharts, so many people have an issue with input, output, and conditions. Okay. This is like where you can maybe get input or print or something like that. Okay. Well, no, I'm sorry. This is the print of the input. This is like assigning a variable. This is the input. Depending on different programs, write a little bit different. Then this could be our if statement or other things as well. So it says connect them with arrows, but never point an arrow inside another branch. Whatever they're talking about there. Okay, flowcharts are great. I don't use them. I mainly use pseudocode if I'm trying to decide something. Yeah, I just think it's easier because we all can write in English quite easily. flowcharts, you need to get the whole graphics program out there. There's something also called UML, which we'll talk about later, that can help us as well design stuff. Okay. So here we have our condition, and the biggest problem people have here is they don't label these. What happens if you don't label them? What happens if I said this one is true? Then we have a problem. When I took college algebra years ago, I actually had a full 100% in the class until the final exam. I forgot to label my graph, my X and Y axis. So the teacher goes, oh, I think this is the x-axis doing this way, so obviously my answer was wrong at that point. I was so embarrassed. I would have had a perfect score in that entire class. No. But yeah, labeling them is kind of important because obviously this says true branch, but if it's not labeled, I might not know that. So people do different things. You can also have multiple outcomes. So if this is true, do this. If it's false, well, then we can check the second one, like our LFs. Do that. I'll check our next LF and so on and so forth. So pretty easy to write both of them. Okay, shipping cost. Inside the US, true. So we basically skip this. We go straight to here. We use contiguous. Are you in the contiguous United States? True, costs $5. If it's false, let's go. You do something for Hawaii and Alaska. So they really need to revise this. You know how we should revise this? We need to start off. Are you at Amazon.com? Prime doesn't matter. It's all included anyway. But you all know, so Amazon Prime is 2-day shipping for free.
Yep.
Yeah.
When it's available to ship, though. Did you all ever see that? It's 2-day shipping for free when it's available to ship. So if it's not available to ship until 4 days, you don't get it for 6 days.
Just good.
But all you got to do is complain to them, and they give you credit. They give you money.
That's the best thing about Amazon. So if this product didn't work, oh, here's your refund. Like,
Yeah.
My wife ordered The Great Gatsby. Is that the book?
Great
Great
Gatsby.
Gatsby.
Yes, my daughter needs to read it in school. So she bought one. It says used book. I'm okay with that. But this book, I've never seen a book with so much marking and highlighting in my life. To the point where you couldn't even read something. So she went on Amazon and said, hey, the book's all marked up. Didn't say it was marked up. No problem. Full refund. Keep the book. Okay. I bought a blood pressure cuff, one that works on my phone, and it broke. So they sent me a brand new one. It was a $100 blood pressure cuff. So I said, do you want the old back? No, you can keep it. And Roy actually tore it apart. We found it was just a fuse blew in it. But by that point, it was totally destroyed. Anyway.
Yeah.
But then my second one broke. And I messaged them again. And they're like, there's obviously something going on. Can you send it back? And I sent the second one back, and they still replaced it, which was nice. But the third one was working fine. So it was obviously something wrong in their system. So I'm glad they got it back. Maybe they can fix it. Okay. All right. So let's see. That's one we just looked at. Okay. Shipping costs are $5 inside the United States, except that to Hawaii and Alaska that are $10. International shipping is $10. Wow, that would be bad. So, if it's inside the United States, found in the United States, false, and set it to $2, that's not a good plan because now there's two ways to get to here. So, if it's not in the United States, or if it is but not in the contiguous, it's just not a good idea to do that. It would just make it very hard to understand. Because you really don't want two different ways to get somewhere. Because depending on who's going to take this flow chart and actually implement it into code, it'd be nice if they didn't have to do it multiple different ways.
So are you saying we should just do a different branch, saying that a different output basically?
Right. What you would probably do is inside the contiguous United States, and I think how we can make that better. You could just set the shipping to 10, but we want to make it so this is not duplicated. So inside the United States, true. Okay, contiguous United States, true, and then this would be the false of it.
Oh, okay.
See what I mean? So it would be this one, and false would, if it was true, it would go and ask this question. If it was false, hold on, how would you do that one? So if it's inside the United States, but outside the contiguous U.S., it needs to be $10.
You should have put the original question inside continental United States.
One more time.
You should have put the original question inside continental United States.
Actually,
Instead of
good.
just
Good
inside
point. So
US.
if we just ask inside continental United States, $5, or else $10. Yeah. But yeah, that would work. Yeah, that would definitely work.
Just
Yeah.
not separate Hawaii and Alaska.
Yeah. They get rid of that whole extra step there. I like that. Is that what they did?
You know, there's
Oh, they
branch
just-
like I was saying.
Yeah, they just separated it out. Either way would work, except wait a minute, no shipping costs. But see, now we got the duplicate statement again. Having duplicate statements is not always a good thing. I like his idea of inside continental United States, yes or no. I think that would be a better choice. Okay, actually, I didn't put that one up there, did I? Did I put shipping up there? Nah, we're not going to do shipping. All right. Okay. Complex decision making is hard. Baggage tags. Wow. Baggage tags is a whole nother. Okay. So it says the computer systems are used to help sort and route luggage at airports. Okay. The system scans your tag, sorts the items, routes them to the conveyor belts, and then humans then place them on trucks. 1993, Denver built a new airport with a state-of-the-art luggage system that replaced the human operators with robotic cars. Nice. It failed miserably. Says the airport was could not open without a luggage system. The system was replaced. It took over a year. Wow, $1 billion. Yeah, $1 billion. Wow. The plan didn't work. The company that designed it went bankrupt. Yeah, obviously they lost money. Crazy. Okay. Test cases is aim for complete coverage of all decision points. So when I worked at Tinker, we had an entire area that just did testing. So if you were going to get input for maybe age, what should you test it with? Exactly. Letters. I mean, check it for numbers, check it for letters, check it for spaces. You need to check every possible thing. You must admit, at one point or another, when you're probably ordering something online, you put the wrong value in the wrong cell somewhere. You had to. It's like I actually imported addresses into Outlook, into my contacts. And one of the people I had in there was Steve Von Neumann at the 38th EID wing at Tinker. And it ended up putting Tinker as his first name, and the 38th is his last name, and the company is Steven. It's like, what the heck? So obviously, whatever import routine they used didn't take into account the format of that email address. So test it with everything you possibly can, and then test it some more. Okay. Okay, there are 2 possibilities for marital status and 2 tax brackets, but there's more than 2. Okay. But in this example, they're saying 2 possible of each yields 4. That's true. If there was only 2 married or single, then they only come up with 4. Test a handful of boundary conditions such as income, what if it's below 0? Okay. I still, still amazes me. We still have to, when you file your taxes, I'm assuming some of you have done this, you have to enter how much you made. Mm-hmm. Why? They should have our W-2s. Because I can literally file my taxes electronically and get a refund with the wrong date. Because how are they going to check it? Because they verify it later and want their money back. But imagine that. If I went on there January 2nd or whatever and said I made, 10 grand and get a big, massive refund check, how long would it take them to find it? Probably a long time. I still think that's wrong. Because there should be something in place to check that better. They're obviously not doing this. They're not catching it up front. But I don't know.
They almost put it on the tax preparers more than they do them themselves.
Yeah, but a lot of people prepare their own taxes. How many of you do your own taxes? What about the rest of you? Don't do taxes?
I do taxes at the community center. For you.
Yeah. I used to do taxes for the military people. So the rest of you just don't file taxes?
Mine are too complicated.
Oh, well, I got self-employment and everything else. But so how many of you don't file taxes? Has to be some reason.
Sorry, don't file taxes?
Oh, yeah. You know you don't have to file taxes?
Right.
Oh, okay, there you go. But if you don't owe money, you technically don't have to file taxes, which is crazy. And then what happens is, the reason I know this is true, we got a letter in the mail last week from the Oklahoma Tax Commission. My mother-in-law, who's now living with us, never filed her 2013 Oklahoma taxes. And they're saying, it's obvious you owed money. See, what the IRS does if you don't file taxes and you owe money, they just take it away. They just do some basic numbers and then just take it out of your paycheck. But Oklahoma doesn't do that. So we literally got the letter. Now we have to go back and pay 2013 taxes. How much interest is that going to be, you think? Probably.
A good amount.
Good thing is, not really a good thing, but she has dementia. So we're thinking we're going to try to, she has dementia, so don't charge us interest. And Oklahoma probably okay with that. But, you know, it's, I don't know, it's crazy stuff the way this whole damn thing works. But back to this. So testing for every possible case is hard. And that's why there's normally professional testing organizations that test everything. What was it? The last version or the, I don't know, a couple versions of the iOS before, they had some deal where if you hit some key like 28 times, it let you in. It was something to do with the contacts. I don't remember what it was exactly. But it was a sequence of keys you could hit that would bypass the lock screen. Who would sit there? And it had something to do with 28 times. You had to like hit something 28 times. Y'all know what a network switch is? Y'all know what a network switch is. All these computers are connected to a switch.
Yeah.
Okay. As far as I can tell, I've never met one that hasn't. Every switch, if they have more than 4,000 MAC addresses, or in other words, computers connected to it, they just default to wide open. So what that means is the switches down the hall have one connection from each computer. So what are you going to have, a couple hundred computers on each switch? Actually, no, you're not. Switches only hold 64 ports. So there technically should only be 64 computers on that port. But you could have a switch to a switch to a switch, and if it ever comes up where there's more than 4,000 addresses, it fails over and it fails to open. They'll even tell you, you can actually read the documentation for network switches. They have, it's called failed open, and it's normally set at 4,000, which means it can only hold that many addresses. The moment you hit that many addresses, fine, give it to everybody, which is crazy.
Come on.
But the funny thing is they know about it because they actually put in the documentation of this error. So they obviously tested it and found the error, but don't want to fix it. Isn't that weird?
Well, like no one's gonna actually get to this point.
Yeah, but it's like,
Why doesn't it feel safe?
because what they do is they actually built a table of addresses. And when the table gets full, in other words, there's a limit on the table. Like the first iOS, I think you can only have 10 icons in a folder or something.
Yeah.
Now you can put a folder inside of a folder inside of a folder. They fixed it so you could go forever. But the switches, that table can't go forever. So if you have 4,000 addresses that are currently connected to it, I guess if you had a bunch of sub switches.
Why does it fail open rather than fail safe?
You got me. They do. I actually was at a class one day and the guy told us it. Sure enough, we even looked at ours down here. They fell open. But again, Switch has 24 ports or even 64 ports. 4,000 is quite a bit. So they probably said, that's enough. Because they have to store that table in memory somewhere.
Impossible.
So you guys, the systems were just basically breached at that point? The fell open?
It would be, yes. Well, it's not that they're breached. The way a switch works is if he sends something to you, okay, you're the only one who's going to get it. Summer's not going to see it, even if she's plugged into the same switch. You fail into what's called a hub. Hubs years ago we had, which everybody saw everything. So if he sent something to you, everybody saw it. That's what hubs were. Okay? But still, Summer's computer over there wouldn't do anything with it because it wasn't an address for her. But we could snip the traffic and see it. So switches solve that by he sends something directly to you. It's the only place it goes. But if you go over 4,000, then it fails into hub mode, which basically sends it to everybody. And your home runners do the same thing. I doubt you have 4,000 computers at all. They probably fail a lot quicker than that. Okay. So when you do test cases, you need to get something that checks all possibilities. above whatever, below whatever, equal to whatever, you know, a negative value, a space, a letter, or whatever. So check the boundaries, in other words, check the top value, check the lower value. Just because you think you're correct, you just test it anyway. All right. It says make a schedule. It says make a reasonable estimate of the time it will take you to design the algorithm, develop the test cases, translate the algorithm into the code, and then test and debug. Okay. So that could take a while. Okay. Do you all know where the most time is spent on software development? What's the most time spent on software development? Not quite. It's actually in the maintenance phase. Think about it. Microsoft released Windows 10, but they've been doing updates forever since then. So the maintenance phase of keeping it updated, which includes testing and everything, you're going to make a fix and test it and everything. But you got the initial development phase, but maintenance is so much more than that. That's why a lot of companies are getting rid of like Microsoft's going through it as well. I think we're good to 2020. We could buy the software for the entire school. You pay a larger fee. They're kind of like, imagine buying a car or leasing a car. Mm-hmm. That's what's happening to the software. You're no longer going to own your software. You're going to rent your software. Okay? You're going to pay the monthly fee. It's like Netflix. Do you actually own anything on Netflix?
No.
No. Can you imagine if you wanted to watch some movie on Netflix and you had to pay for everything to do with that? I mean, you could never afford it. You couldn't pay to have the movie made and pay everything. So what you do is pay a small fee. But that's how a lot of software started to go to.
It seems like the business models for a lot of companies are moving towards subscription services.
Right. That's exactly what it is. Because they make more money. I teach a reverse engineering class, and it's funny because the teacher that taught the class when I took it, he gave us a piece of software that he even had proof. He bought a lifetime license for the software. I have a couple pieces of software like that. I bought it and never paid another penny. Okay. Well, he bought the lifetime license for the software. Then about 4 years after he bought it, they changed their licensing model and said lifetime software is no longer being supported. So what the heck? I mean, what does lifetime mean? For life. But their thing was, oh, it was only the lifetime of that release, which is bullshit. But, it's life. But yes,
That's what you get for paying lawyers lots and lots of money
Yeah,
to find loopholes.
So when making your schedule, just, it seems that the more time you put into the development, in other words, the designing area, you end up paying less later on. Okay. All right, I think that's enough for today. We're going to pick up next time on slide 65, and we'll finish the chapter.
I gotta go. Well, driver's test.